Hello everybody. Today I'm going to talk a little bit about our Model 9403 Advanced Mixing Condensation Particle Counter. This unit right here. The mixing-based CPC counts the total number of particles in the air between about 7 nanometers diameter and up to a couple microns in size. And the way it does that is by bringing in a sample flow that comes in through this sample inlet and mixing the sample flow together with a butanol-laden airflow in the condensation chamber. We grow the particles into micron-sized droplets, and then we count them in an optics block, which is right at the top of the unit right here. One of the key advantages of the mixing CPC, unlike a lot of other condensation particle counters, is its speed. It uses a completely different physics, which is a carefully controlled turbulent mixing of the sample and the saturator flows to create a very, very fast response time, about 180 milliseconds. So the unit is ideal for applications where you need to have a very fast response, like UAV or aircraft measurements, or other conditions where your aerosol population number concentration is varying a lot with time. Let me briefly walk you around the instrument so you have an idea of what you're going to be looking at when you get your unit and you need to set it up. Again, I mentioned here that we have our sample inlet. This is a stainless steel inlet. Typically, people are mating to this with the black conductive silicon tubing. That's very convenient. And you can see here that we have a tube labeled air inlet. This is actually the inlet for the saturator pump. There's a very small saturator pump right in the front here that's drawing in air, and it's acting like a little compressor. It's pumping the air through these filters, and then that flow is measured in a laminar flow element, which is this metal assembly with the red and black tube right here, before it flows into the saturator. The saturator is this box in the bottom here that's kept warm at 45 degrees C. That's where the liquid butanol enters when you connect the butanol bottle that comes with your unit to the fill connector. That's how you fill butanol. Your unit will arrive dry, so it will not count particles until you actually add liquid butanol. You want to use reagent grade butanol for this unit. It's highly recommended, especially for mobile applications where the unit is shaking a bit because you're mobile, that you actually fill the butanol at the beginning of your experiment. Make sure that your unit is fully full. That means wait about 20 seconds or so, and then disconnect the bottle and operate the unit without the bottle connected. That will get you roughly 6 hours of runtime before the counting starts to drop because there's not enough butanol liquid in there. So you can actually run a long time without the butanol bottle connected to this fitting. So as I mentioned, the sample flow is entering here. The saturator flow is coming in through this tube. It's often a good idea to put a filter on this tube to protect the pump from dirt and dust. The flows are mixing inside the condenser, which is just below the optics block, which is this top insulated. The optics block is this top insulated block here. And then the mixing of the sample flow and the saturator, the warm saturator flow, in a 20 degrees C condenser block causes condensation to happen very rapidly on the particles so that they grow up into several micron drops, and the combined flow flows up into the optics block where a laser is detecting individual droplets. We only do individual droplet detection. We do not use any kind of photometric type detection in this particular CPC. You'll see here a front panel display. This is what you can use as your interface to see what all the instrument operating parameters are. You connect it here via a ribbon cable at the very top edge of the control board. This is the main control board here. And you'll notice that the cable has a black color on this face. That black color on the ribbon cable has to match with the brown connector clamp. Okay, that's how you know which way to put the cable in. Be sure to only put the cable in and take it out when power is removed from the instrument, which is right now. I do not actually have the power connected. All right, continuing around the unit here, you can see here, this is the exit vacuum pump. This is the pump that's drawing all the flow out of the optics block. So the saturator and the sample flow have combined inside the unit. They're coming out through a critical orifice on the side here. There's some dilution flow that's added to bring down the butanol concentration. And then this vacuum pump is constantly sucking on that orifice to control the total flow coming out of the optics block. So this tube here, which is labeled exhaust right here, this tube has butanol airflow coming out of it. And you need to route this tube to either outside or a fume hood or somewhere where air with butanol can go so people don't breathe it. Okay, that's very important. Okay, so what else can I show you about this unit before I actually power it up? You can see that this is somewhat of an OEM design. No covers. That's to keep the unit as small and compact as possible, but it also means that users need to beware these boards are exposed and are sensitive to static shock. Do not touch the boards during operation. Be sure when you mount the unit, you use these convenient mounting tabs that we provided. For example, here, just like this, right through the metal bracketry. You can use standoffs underneath if you like, or you can just let this bottom surface rest right on a plate, for example, so that you can hold this down nice and solid. You'll see here a connector sticking out. This is actually to attach a cooling fan that is supplied with your unit. So let me briefly go through the ship kit. This is a ship kit that's typically supplied with each unit. Okay, this is a BNC cable that has a small SMD connector on one side here that screws into the main board only if you want to detect individual pulses from the unit. Most customers don't actually ever use this. You'll see here a cable. This is for RS-232 communication. If you want to hook to a computer where you have a serial port, you can actually talk to the unit and control it. And this 3-pin black connector here, you can see inside the bag, actually connects right to the back edge of the board, right here. Right here. Okay? So that's where the serial communication cable would connect only if you want to do serial communication. If you purchase our Access base module, a ruggedized tablet that I can talk about later, then you won't need the serial cable connection. You'll use the USB cable. Here's an example of one way to supply 12-volt power to the unit. This is the power connector that plugs into the board. Let me show you the connector is right in here. Okay, it's a little bit challenging to get to. You can see it right there, the 2-pin connector. So you can plug this cable in and then tie this right to your 12-volt battery. You solder or crimp to these wires. Or alternatively, if you purchased our power supply, which is here, this power supply is just a standard AC/DC power supply. It comes with the AC power cable that is for your country. That will plug into this power connector, okay, which is also supplied with the unit. So to connect that, you see the tab here, all right? That has to lock into the tab that's on the board. So just push it in. You can see now I've mounted it inside here, okay? And then the next thing you want to do is go ahead and hook up the power supply. I have a power supply already set up here for myself. And you'll just power this right up, like that. Okay? So you can hear the vacuum pump going on now. This unit doesn't have any butanol in it, so I'm not worried about breathing this. One thing you can do to reduce the noise is simply put a filter on this tube. That will help dampen the noise so you don't annoy your lab mates. And then let me let me show you a couple of the other hookups real quick. This cooling fan is supplied as part of your ship kit. You can see it has a simple 2-pin connector on it that plugs right into the 2-pin cable that's sticking out here from your unit. So just go ahead and plug it right in. You can see the fan starting to blow. And what you want to do temporarily is you can use this to simply blow cool air on the condenser assembly inside, because we want to evacuate that hot air that's being generated by the saturator that's kept at 45°, and the hot air that's being rejected by the coolers on the condenser. Now, when you create your installation and you mount the mixing CPC, you need to find a place to mount this so that it's rigid and held right in the right place, something like this. You can blow from the back here as well, behind the unit, but you need to mount this fan, or you need to use some other cooling air that you have available and direct it into the unit so that the unit gets cooling air so that it can really operate as well as possible. Okay? So let me show you a few other things that we have in the ship kit. To receive an assembly like this is what we call our saturator bypass. And what that means is, let me show you, you can actually install this Swedge lock T, I'll just leave this up here, on the inlet, like this, okay? Should come with nylon ferrules, so you're not going to crimp on the stainless tube and permanently install the ferrules. Alright? And then what can happen is if you tie the saturator pump inlet that I described earlier to this tube here, you can hook it right to the barb fitting, you can pull this guy off and hook it right to the filter. Alright? The idea is that this will let the saturator pump pull its inlet flow from this T. Here, there's a mixing orifice at this entrance. You'll see a small orifice hole. That's to mix the particles so that we know we get a good split in this T. Okay? And then 0.36 liters of flow are going to go back and around this way through the saturator pump. 0.36 liters of sample flow will go through the inlet here. Alright? So, let me show you briefly the display interface here, if we can get the camera close enough so that I can actually show you this. So let's see if you can see this here. Not sure how easy this is going to be to show. Alright, so you can see it's telling me to refill the butanol. That's because the unit's dry. Okay? And by scrolling, by turning this knob, you can explore the different menu options here. Can't really see that very well on the camera, so I don't think I'm going to show it to you like this. I'll have to do that a different way. Alright, so what else is there to say about the unit here? If you were going to use the Access Base module, so that's an option that you can purchase that gives you a very nice user interface software that can run on a ruggedized tablet for multiple hours without AC power. Then what you would do is you would actually connect in to the USB port, which is right here on the top edge of the main control board. Alright? And that's just a standard USB cable that's part of your ship kit right here. You can see the mini and then the standard USB. And that connects into a simple hub that comes with the ruggedized tablet. Alright? I'll be talking in another video about the control software and using the control software. So that's pretty much the basics on how to set up the Mixing CPC and what the details are of the overall system. Feel free to email us at sales@brechtel.com if you have any other questions, and I hope you enjoy your sampling.